Hi guys, I wanted to share with you what you're going to be doing today since there's really no point in recording what's going to be going on in class because most of the time it's just going to be spent taking a test. So the best way to summarize it up on the board most of the class period, I'm going to have this sitting up on the screen. So your first objective once we're done the opening question is to make sure you do your study island. You're going to submit it as an assessment, so I'll show you how to do that when you're done. And then you're going to continue your biointeractive worksheet from yesterday. Understand if you don't finish your benchmark today, you're going to get a chance to finish it tomorrow. So I'd ask that you only work an hour on this and then know that tomorrow you'll have more time in class to finish it, but it usually never takes student more than 90 minutes to complete it. So for today's opening question, when it says, what are the four major divisions of Earth's geologic history, starting with the longest segment? So if you think of this like a calendar, the eons are the largest, and those are broken up into eras. And then those eras are broken up into periods, and then those periods are broken up into what's called epochs. So just like a calendar has months, then weeks, then days, then hours. It's the same thing when you talk about geologic time. So to answer this question, you can say the largest segment of geologic time is eons, which are broken into eras, which are divided into periods, which are divided into epochs. So an epoch is a really tiny, small amount of time, and an eon is a really long period of time. So for your study island benchmark, when you look into your Schoology, it should say today that you have an assessment due. So this is kind of literally all you're going to have to do through Schoology. When you click into Clever, it's going to take you to this homepage, and mine looks a little bit different. But when you go into your Clever, you are going to pick the little palm tree. So I don't know how many icons you have, but that's how many I have. So if you hit Study Island right here, it should pop up on the screen. So that pop up on the screen will show you that you have a science benchmark to complete. When you are done, if you go into your Schoology, this is your one question. It says, I have completed my study island benchmark for science, including the short answers. So this is going to count as an assessment grade, but it's based on your effort, not how well you answer all those questions, right? And that's what's explained to you in the directions. So check off either one. I've completed it and tried my best on everything, including the short answers. And yes, I completed the benchmarks, but struggled with the short answers. So just want to see how you guys feel about the short answers before I actually grade them. So as far as today's agenda, that covers item number 1 and 2. For number 3, your biointeractive is this worksheet that we started yesterday. So yesterday, you should have gotten up to and including question number 4. So for question number 5, which is click on the view box in the bottom of the globe and check off cities. Click the following view icon again and hide in the list. Spin the globe to find various cities in the regions. So if you click on the website that's there, so pick the Earth that's currently on our globe. So I think it starts with South America. So that's South America, and there's 1, 2, 3 cities that are listed. So when it says cities, as long as you name 2 of them, that's fine. In North America, you now spin the globe up like this. And I'm gonna, if you zoom in a little bit, it's probably gonna be easier to read. You have Los Angeles, Chicago, Toronto, Washington, D.C., New York. Those would all count for North America. And then Africa, if you spin it over to Africa, we have Cairo, Lagos, Namibia, Johannesburg, and Kinshasa. And then the last one, Australia. You zoom in all the way over to Australia, you got poor little Sydney all by itself, and that's it. So then when it says find Washington, D.C., and move it to the middle of the globe, describe how the location and composition of Washington, D.C. and North America have changed as you move the silver bar down the era. You will have to spin the globe to keep track of how the continents move over time. So you're going to start with the mid-Cretaceous. If you take your planet and you spin it, so you have Washington, D.C. kind of in the middle, right? So I'm going to zoom in just a little bit. So I'm going to go to the mid-Cretaceous. So right now I'm going to just move it down a little bit. And if you watch that little purple icon, Washington, D.C. is kind of moving. So as time went on, right, it got further away from the prime meridian because our Atlantic Ocean was spreading apart. So if you talk about how it's changed now, look at it. It's a much tinier landmass, and it's pretty much a shallow sea at that point. So for this one, you could say it's a shallow sea that is a lot further east than it is now. So if you go to the mid-Jurassic, now you're going to move it here. So now if you look at it, it is a lot closer to Africa, and that landmass has gotten a little bit bigger, and it's not quite over in the water. So for the mid-Jurassic, you can say it's near a much smaller Atlantic Ocean, and that the landmass is small. The mid-Triassic, so now we're going to keep on rewinding it. So now keep on looking where Washington, D.C. goes. So now Washington, D.C. is almost attached to what we call Africa. However, it's not really the same thing because this is where Pangaea was, right? So this is right before Pangaea was breaking up. So if you watch, that's when Pangaea was still a thing. So if you talk about how old our mountains are, this is right after they formed. So for this one, for the mid-Triassic, you can say it was part of Pangaea. And then the mid-Devonian. So if you go down here and go, keep on scrolling to watch how far down DC is going. So now you kind of like lost Washington, DC. So it's all the way down towards the South Pole, okay? You still got that ancient mountain range there, but it's all in the mountains and it's all in the southern region. So for this one, you can say it's on the South Pole in an ancient mountain range. And then for the Cambrian era, now watch it again. So now we're even still going further and further over the North Pole, or South Pole, sorry. And if you watch, so now Washington, like that's the South Pole, that's where it is. And if you watch how much it's changed, it's literally right over this South Pole. So for that last, and it's in the ocean, so it didn't really even quite make it onto land. So for this one, you can say it's over the South Pole and not part of the landmass. So next one where it says click the view icon and select the global event. Click the view icon again to hide the list. Starting in ancient Earth and moving into the Paleo Earth section of the geologic events, give in millions of years and a description of what occurred. So what you're basically going to do is you're going to go, let me reset it. So you're going to hit view, you're going to hit geologic events. So you're going to go here, and as you scroll your ruler down, that pops up. So that one's Pangaea, that one's oxygen. If you go down towards the bottom, there you go. So if you click, get rid of views, if you click moon forms, it gives you a little description. So that's the time range you're going to put in. And then you're going to give me over here where it says description of what occurred. You can just tell me about what they hypothesized, right? So something collided inside of Earth, and what was basically ejected from us, that's what formed the moon. So you're going to keep on going through that. So you're going to find all those events and give a description. For number 8, you're going to do the same thing, but now you're going to get rid of geologic events and you're going to click on biologic events. And same thing, you're going to move your cursor up till you hit it, and it'll tell you what actually happened, right? So if you get rid of views, click that, it'll give you a description. So that's how you do number 8. Number 9 is the same thing, except for here, you're going to click where it says mass extinction. And then number 10, you're going to do the same thing, but for fossils. And number 11, major impacts, okay? So that's all you need to do to finish up your biotech. It isn't due until tomorrow, so you still do have some time tomorrow to work on it. So for your closing question was this, why is there little geological evidence of the Hayden Eon on Earth? So if you look at the Hayden Eon, it was so very stinking long ago that our rocks have gone through a lot of changes. Like we've continuously gone through the rock cycle. So to answer this, you can say since the Hayden Eon was over 4 billion years ago, few remaining rocks have not been destroyed by the rock cycle. So that's all you need for today. If you have any questions, please feel free to email me. All right. Have a good day, guys.